Today in class we talked about how to use the quadratic formula. And to begin, we can use the formula when our equation can be written in this form. That's a very important thing to understand because this formula doesn't mean anything unless what we're working with has this form. So before we start plugging A, B, and C in, we first need to make sure that our standard form equal to 0. So I'm going to demonstrate that on two problems, and in the process show a strategy that I use to organize my work. So with this first example, I need it to be equal 0. So I'm going to add this 4 to the other side of the equation. So what I'm dealing with now is the equation 2x squared plus x minus 8 equals 0. Now the formula is full of the a, b, and c. So a is 2, b is 1, and c is negative 8. Oops, c. So what I do now is I chunk together parts of the formula, the negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to color code it for this example. I'm going to do negative b. That would be negative 1. Then I do this whole part. I do the b squared, which is bb minus 4ac. So that's 1 times 1 minus 4 times 2 times negative 8. And if you're going to do this in the correct order, make sure you do the 1 times 1 by itself, and then you do all of this by itself, because the multiplication has to happen before the subtraction. So the double negative makes it positive, and ends up being a plus 64. So 1 plus 64 is 65. And then we can square root that, and that's going to give us, we have to use our calculator because 65 is not a perfect square. But we square root that, and we get 8.062, and it keeps going. But I'm going to round to 3 decimals. So that process, the bb minus 4ac, that takes the most amount of time. And then we'll do the denominator, double a. So double a would be 4, 2 times 2. Okay, so by doing that, we now have these 3 numbers that we can put in this fraction. And notice that the formula has a plus and minus. So we actually have to do 2 fractions to create our 2 separate solutions. So I'm going to take my opposite of b, and I'm going to add the green part. And then I'm also going to take opposite b and minus the green part. And each of those are over the 2a, which is 4. So I could color code that. Here was the negative b. Here was the square root part. And then the 2a part. So this numerator, negative 1 plus the 8 is 7.062. This here is negative 9.062. And now we can finally divide. So we do the 7.062 divided by 4. We get that x is approximately 1.766. And x can be negative 2 point, let's see, 2 point something. 2.266. So these are the 2 solutions to that original equation. All right. So I'm going to do the same thing for example number 3. What's different here is that all 3 terms aren't visible. So we have 3x squared minus 5x equals 0. So there's a couple things I want to emphasize. So a is the quadratic coefficient, b is the linear coefficient, and c is the constant. So here where we don't have a constant visible, so we can say that it's plus 0. Okay, and 0 is a number, and anytime we see c in the formula, we have to put 0. Sometimes students ask, hey, if c is 0, do we even have to put it in there? Definitely, because we are multiplying by c, and multiplying by 0 has a major effect on the outcome. So here we go. So negative b is positive 5. I'm going to do 2a So 2a is 6. Then we have the bb minus 4ac, and then we'll square root that. So -5 minus 4ac. Again, the 0 is actually nice here because 0 times 3 times -4 is all 0. So we end up with 25, and then that value is square rooted to be 5. So now we have our 3 components. And again, this is one example of how I organize it, setting up these 3 chunks and then putting them all together to get the solutions. So x is the opposite of b plus the square root over the 2a, and opposite of b minus that square root over 2a. Now when we simplify this, that gives us 10 over 6, which simplifies to 5/3. And we have 0 over 6, which simplifies to 0. And yes, 0 is a solution. So we have 2 distinct solutions, 5/3 and 0.